Hey, John here from WCS Machinery. This video is a tutorial on how to use the centrifugal compressor testing application. There's also a link to the tutorials in the upper right corner of the web page right here, which will take you to my YouTube page. Now let's get back to the testing application tutorial. To get started, press the My Dashboard button. The dashboard will list your previous test files where you can edit or view that particular test. But to start a new test, simply press the Add New Compressor Test button. Get started by entering a name for our compressor test. So in this case, I'll call this K101 compressor test. Now let's enter a temperature. So our inlet temperature for this test is 37.47 degrees centigrade. Now we can select degrees Fahrenheit, Kelvin, or Rankine, and if we select any one of these units, we'll notice that the temperature range changes accordingly to the units selected. So let's go back to centigrade. Now let's enter in a pressure of 36.5 bar absolute, and in like manner we can select kilopascals absolute or PSI absolute, and again the pressure range changes according to the units that are selected. So let's go back to bar absolute. So now we need to enter in the last impeller diameter, and in this case it's 700 millimeters. We can select millimeters or inches, but in this case it's millimeters, and our design speed, which is 5100 RPM. Now we're ready to enter in the design curve information. So we'll start with selecting the flow unit for the inlet flow for the curve. And in our case, we're going to select cubic meters per hour. You can see there's a number of units that we can select. So we'll scroll down to cubic meters per hour and select that. And then also we need to select the head unit for the compressor curve. And in our case, it's kilojoules per kilogram. So we have three other units that we can select, but we'll select kilojoules per kilogram. So now let's enter in for the very first point, which will be the surge point. So let's enter the inlet flow of 41,192.8 and a head value of 109.724, and then our efficiency at that point would be 82.1, and this is according to the manufacturer. The next point is an intermediate point, so we'll enter that data, and this intermediate point will be between the surge point and our operating point. So bear with me and we'll enter this information and it will make sense as we go. And we have a head unit at that intermediate point of 109.337 and an efficiency of 82.5. Now finally our operating point, which is sometimes might be called the guarantee point, but in this case I call it the operating point. So we'll enter that data, so 47,229.1 for the flow, and that's in cubic meters per hour, and then the head unit for that for our operating point is 105.246, and the efficiency is 83.8. Now we have another intermediate point, which will be between the operating point and the end of curve. So for that value, 52,460.5, and the head value is 98.363, and the efficiency is 83.1. And our end of curve, which could be the stone wall, or it just could be the last data that the manufacturer publishes in the curve. So either way, but that's your choice of what to use as the end of curve, or the end of the data that you wish to display. So in this case, it's just the last data that on this test that the manufacturer provided. So in that case, it's 57,691.9 cubic meters per hour, and the head value of 89.036, and an efficiency of 80.3. So that is our curve information. Now that's helpful, but we do need a composition to accompany that. Well, from this drop-down list, we can select from a list of existing compositions that we may have used on previous tests, or it may be currently listed. And in this case, it's called the LGR. But don't select that right now. We'll go make a new one and we'll call it LGR1. So to do that, we would select this Manage and Add Composition button, which will take us to the composition editor. So we want to, up here at the top, we can edit some other previously defined compositions, but more importantly, select the Add New. So when you can give it a name, so again, we say we're going to call this LGR1. So now that we've got the name in, the idea now is to select a gas from the left side and then add selected gas, and it will move it to the right side, which becomes our composition, and then enter in the mole percent for each value, or for each component of the composition. So let's get started. Let's add the first component, which is nitrogen. So we'll select nitrogen, and then we'll add that selected gas. So then I'll double click in the mole percent area, and I'll enter in that value, which is 4.213%. And if we notice up at the top, our red box here to the right is telling us the difference from 100%. So that'll come in handy as you get toward the end, especially if you want to check to be sure that you have 100%. So the next component is methane, or C1. So we'll find methane in the list, and we'll add that. Double click, add its value of 90.401%. That's mole percent. The next component is C2. We'll find that in the list here, ethane. There it is. Add that. Double click. Enter that value of 5.335 mole percent. The next component is propane, or C3. So we'll find that there on the list, and we'll add that. Double click. Add the value of 0.01%. And the final component is helium. So we'll find that in the list. There we are. Add that. Double click. 0.041. 0.041. There we go. Okay. And then the box turns green, tells us, okay, we have 100%, which is what we need to have. And if we don't, then we can go back and check all of the values that we've entered to be sure we've entered the right number. So once that's done, we just press save. Save it, and then we're done. So now we can come back over here and select LGR1 as our gas composition. So now we can plot the design curve. So we see the plot at the top shows us the head versus flow, and then if we highlight or hover our mouse over the curve, we can see where the different data points are entered. So we have the head values and the flow values that are highlighted, and then the curve below is the efficiency versus flow. And again, if we hover over the curve, we can see the different values of where they are on the curve. We can also calculate the discharge pressure, discharge temperature, and gas power for this design curve by pressing this button. And again, we see that there's two plots here to where the discharge pressure is plotted on the left vertical axis and the discharge temperature is plotted on the right vertical axis. And then we can see the two different colors for the values that are calculated. And the gas power below in the plot below. Of course, it's just one curve, but we can also see the values as we hover over the curve. And we can also show a data report, which is a text output of the information that we entered. And there it is. So that gives us just a check to be sure that we entered all of the data. And also, if you want to add this to your test report, you can. But it also gives you, of course, the test information, the basic suction pressure and temperature and speed, but it also do a head rise to surge and a pressure rise to surge, along with the gas composition that was used. So now let's go back to the test. We just press this return button. And we'll press the plot design curve button just to show our plots again. So now we've entered the design information and we're ready to enter in the test information or the test data.